Sample size determination for estimating mu. In a previous section, we stated that as long as n is larger than or equal to 30, then that sample size was large enough for us to use the confidence interval formulas and assume that x bar was normally distributed. We should note that just because you're able to use the formulas does not mean that the formulas will actually produce useful results. For example, if someone stated that they were 95% confident that your starting salary on your first job will be $50,000 plus or minus $45,000. This absurdly large confidence interval, even though we were able to use the formulas to produce that interval will not produce useful results. Whenever your intervals are too large, the problem is you didn't sample enough items from the population. If you had sampled everyone in the population, you wouldn't have needed an interval. You would have had an exact value for your population mean. So the question becomes, how many people should I sample in order to get useful results? If we define E as the maximum sampling error mentioned in our precision statement, and E is actually the amount that's after the plus or minus symbol in our confidence interval formula, E is referred to as our margin of error. For our confidence interval formulas, our margin of error had this structure. And if we solve this formula for n using algebra, we will obtain that n is equal to z alpha over 2 times sigma divided by E. All of that squared. So if you sample at least this many items, you will obtain a margin of error in your confidence interval formula, which is E or less. An example. A consumer reporting agency wants to conduct a study to determine a 95% confidence interval for the mean number of miles that a certain SUV can travel before needing an engine tune-up. The population standard deviation is estimated at 5,040. If the agency desires a confidence interval with an error of plus or minus 1,000 miles, what sample size is required? At 95% confidence, our Z alpha over 2 value is 1.96. Using our sample size formula, we plug in our Z alpha over 2 value, our standard deviation value, and our max desired error 1,000, and we obtain 97.58. Since we must sample at least 97.58 items in order to produce that error of 1,000 or less, we must sample 98 people. Please note that regular rounding rules do not apply for this problem. Even if this value was 97.1, since we have to sample at least 97.1 people, and unless we're going to chop someone off at the ankles in order to get 0.1 of a person, you should always round that number up to the next integer in order to determine your proper sample size. Hands-on practice. A researcher wants to estimate the mean starting salary for an undergraduate business administration graduate with 95% confidence. They want to make this estimate with a maximum error of $1,000. It is known that the population standard deviation for starting salaries is $6,200. You should pause the video at this time and use our sample size formula to determine the appropriate sample size in order to obtain a max error of $1,000. For this problem, for 95% confidence, our Z alpha over 2 value is 1.96. Our standard deviation for this problem is 6,200, and our max error is 1,000. So if we plug this into this formula, we obtain 147.67. So we must sample at least 147.67 or 148 people in order to obtain a max error of $1,000 when we estimate the population mean for this problem.